In Excel, there is no function called unique, and yet the need to count the number of unique entries within a column or within a range can be really important. In this particular worksheet here, we've got a number of different departments here. In this worksheet here, and I'll double-click the bottom edge of one of these cells to show that it goes down to row 687, we've got a lot of different departments in column B. If we sort the data, it'll pull all the data together by department, but that doesn't give us a count of how many different departments we have. And so in this list, the need for counting the number of unique entries in column B is apparent. And this list might grow, it might shrink. We're going to show you two different ways to do this. One will require us converting the list into the table. We'll get to that after first showing you how to work with the data using a very unusual function that's an array formula. We will first show you how to get this unique count using an array formula that's very unusual. The formula is as follows. Now, I saw this at first about 15 years ago, didn't truly understand it, but I did realize that it worked every time I tried it. So let's show what it is. Equal sum, left parenthesis, 1 divided by, and then we're going to use the function after a left parenthesis, countif, left parenthesis. We can't use the entire column reference, so we have to put in the address. It's B2, and I'm simply highlighting a portion of this, save a little bit of typing time, down to 687, comma, and we need to use this all over again. Now, you might be familiar with the countif function, but the way it's being used here is a little bit different. So I'm simply copying this part of the address and pasting it here. Right parenthesis, notice the color coding of the parentheses, another right parenthesis, and we're done. It works. There are 24 different entries there. If we do this with a smaller list, perhaps the logic of it becomes a little more apparent. Here's a much smaller list containing different states. And if you look at that, this is a much smaller list simply containing a number of different states. Colorado, Kentucky, California, and Ohio. Those are the only ones. If we use the countif function in its basic form here, simply to tell us how often, for example, Colorado appears, we could simply refer to column K here. There's nothing else in the column, comma, and then click this cell to see how often Colorado appears in the list. 4 times. And if we copy this down the column by double-clicking, we haven't really achieved a whole lot. But if the question were to somehow come up, what does this entry represent as a portion of all of the Colorado entries? Well, it's 1/4. And so if we alter this formula that we have here and put in 1 divided by countif, complete that and recopy it, we're not seeing the actual percentages, but that, of course, means 25%. If we were to highlight our various Colorado entries here, we would, in effect, be saying each one is a quarter, therefore they add up to 1. Similarly with Kentucky. But California has 5 entries here, so each one of these is 20% of the California entries. Only 3 Ohio entries, each one of these is a third. So what happens when we highlight all of these? What are we getting? A sum of 4, and of course that tells us there are 4 different states. So in a much larger example that we first saw, the same kind of logic is being used. And it's not exactly apparent at first, but you saw what happened over here, comparing that formula with the formula we saw over here. Here we're comparing a set of countifs as well, and then dividing by 1. But we cannot achieve this without pressing Control-Shift-Enter. Now, if our original data is in a table, it's a little bit simpler, and it has the added advantage of if the table grows, we will always have a correct answer. So let's convert this data into a table. A quick way to do this is Control-T. You can also press Control-L or go to the Insert tab or the Home tab. This is reasonably fast. Click OK. There it is. Now, since this is a table, we'll start our formula over again, pretty much the same as we did before. And to make this formula visible, I'll use a new function in Excel 2013, equal formula text. It simply allows us to display the text of a formula located elsewhere. There it is right there. So let's keep that in mind and keep it in view. And we'll start off typing equal sum, pretty much the same as the previous use of the formula. 1 divided by, left parenthesis, countif. Now, I just created a table. If I type the letter T, not only does this expose formulas, but it exposes any tables that we might have created. And there it is right there. I'll just click it and tab into place. And a characteristic of tables is that we automatically have field names. So I'll press left bracket, and we see the field names in the table. The one we're interested in is department. We'll just click that right there, tab it into place, and then a right bracket, comma, And then we do this all over again. So we could either type it or copy it. I'll simply highlight this data here, press Control-C, click over here, press Control-V, some more right parentheses again, and Control-Shift-Enter. And that gives us the 24. And let me display that. I'll simply double-click it for the moment. Compare that with the previous use. It's a little bit longer, although only slightly. But it does have the added advantage, since this is now a table, of being able to account for new entries. And so if we add new records, and that entails some new departments, this use of the function will automatically adjust, whereas the previous use of our array formula will not. So I think you can see the real power of this. And one of these years, I do expect to see a function in Excel called Unique, which will allow us to get to this answer more easily.